Taste is one of the most powerful senses we have, allowing us to experience the world through flavor, a sensory connection that can bring memories, comfort, and sometimes even surprise. Yet, despite its importance in daily life, many people don't stop to think about the complex systems at play behind our ability to perceive taste. One crucial factor in our tasting experience is something we often take for granted: saliva. While we may instinctively associate saliva with being an unpleasant, excess secretion in our mouths, its role in taste perception is indispensable. Without it, the experience of taste would be incomprehensible and much more limited. Saliva, produced by the salivary glands in the mouth, plays a multifaceted role in the digestion process, but its most direct contribution is to our ability to taste. The process of taste begins when chemicals from food dissolve in the saliva. This is a crucial first step, as the molecules from the food must be broken down into their chemical components to activate the taste receptors on our tongues. These receptors are specialized to detect different taste qualities, such as sweetness, bitterness, sourness, saltiness, and umami, but they cannot function unless the food's compounds are dissolved and carried by saliva to the receptor sites. Essentially, saliva acts as the vehicle that transports food particles to these taste receptors, which then relay the signals to the brain, where they are processed and interpreted as specific flavors. The structure of saliva itself is another reason it is so vital in taste perception. It is made up of water, electrolytes, mucus, and enzymes, all of which are essential not only for breaking down food but also for keeping the mouth moist and lubricated. Saliva helps break down large food particles into smaller ones, a necessary step for effective taste perception. For instance, when we chew, the mechanical action of our teeth breaks food into smaller pieces, but it is the saliva that moistens and dissolves the food, making it more accessible to the taste buds. Without enough saliva, the food would remain dry and less capable of releasing its flavors. That is why a dry mouth, often caused by dehydration or stress, can significantly diminish our ability to taste. The lack of moisture means that the chemicals in food cannot be fully dissolved, and therefore, fewer taste receptors are activated. Beyond its ability to dissolve food particles, saliva also contains enzymes, such as amylase, which help in the initial breakdown of starches, further altering the flavor of the food as it enters the mouth. This enzymatic action also contributes to the process of digestion, allowing our bodies to begin the breakdown of food molecules before they even reach the stomach. The enzymes in saliva may also modify the chemical composition of certain foods, enhancing or altering their taste. For example, the sweet taste we experience when eating starchy foods like bread or potatoes is, in part, due to the amylase in our saliva breaking down starches into sugars that stimulate the sweetness receptors on our tongues. Saliva also plays a key role in the perception of food texture, which can influence the way we taste. The viscosity of saliva is crucial for how we experience the mouthfeel of food. Thicker foods, like cheese or peanut butter, require more saliva for efficient breakdown and swallowing. As we chew, saliva helps lubricate the food, allowing it to move more easily through the mouth and down the esophagus. This lubrication also allows for a smoother interaction between the food and taste receptors, ensuring that flavors are delivered consistently. Without saliva, the food would not glide as smoothly over the taste buds, making the tasting process less efficient and less enjoyable. Another fascinating aspect of saliva's role in taste perception is its ability to affect our overall sensitivity to flavor. Studies have shown that the amount of saliva in the mouth can influence the intensity of the taste experience. For example, individuals who suffer from conditions that cause dry mouth, known as xerostomia, such as certain medications or autoimmune disorders, often report a reduced sense of taste. This reduction can lead to difficulties with eating, as food can seem bland or unappealing without the proper balance of saliva to enhance flavor. On the other hand, increased salivation, which can happen in response to specific foods or in anticipation of eating, can heighten our sensitivity to certain tastes. This explains why food often seems to taste more intense when we are particularly hungry or excited to eat. Saliva also plays a role in the protection of taste receptors. The salivary glands constantly produce saliva, ensuring that our mouths are consistently bathed in a fluid that helps wash away food particles, bacteria, and other debris. This protective function is especially important for maintaining the health of the taste buds, which can become overstimulated or damaged if food particles or bacteria build up too much. Saliva helps maintain a clean environment in the mouth, ensuring that the taste receptors can function optimally. It also helps neutralize acids from food, protecting the teeth from enamel erosion and promoting overall oral health. Additionally, saliva helps modulate the way food tastes by interacting with the molecules in the food itself. The molecular structure of certain foods may make them more or less compatible with saliva, affecting how well the chemicals from the food can be detected by the taste receptors. For instance, some foods release their flavor more easily in the presence of water, while others require a more substantial amount of saliva to properly dissolve and deliver their taste. Spicy foods, which often contain compounds like capsaicin, are another example of how saliva affects taste. The more saliva present, the better our ability to dilute and manage the intensity of spicy flavors. The absence of saliva, then, results in a significant loss of taste perception. The dry mouth that occurs during illness or dehydration not only reduces the quantity of saliva but also its quality, making it difficult for food particles to dissolve and interact with taste receptors. People who suffer from dry mouth due to medical conditions such as Sjogren's syndrome or as a side effect of medication often experience reduced enjoyment of food, as their mouths cannot properly process flavors. Similarly, individuals undergoing certain treatments, like chemotherapy, frequently report a diminished sense of taste, which can be attributed to changes in their saliva production. In conclusion, saliva is far more than just a bodily fluid that moistens the mouth. It is an essential component in the process of tasting, playing a role in dissolving food particles, enhancing the delivery of flavors to the taste receptors, and even modifying the taste itself. Without saliva, the complex and pleasurable experience of tasting food would be impossible. Saliva allows us to enjoy the myriad flavors and textures that food provides, and its presence is vital not only for flavor perception but also for the overall enjoyment and effectiveness of the eating experience. From its enzymatic actions to its role in taste receptor activation, saliva truly is the unsung hero of our taste perception system, without which the simple act of eating would become far less enjoyable, and perhaps even unrecognizable.